Okay, 6.6 is all about function operations, so I'm going to dive right into the basic function operations. And you should see that what we do with numbers, we also do with functions, okay? So what I mean by that here, so let's start off by saying, let's let f of x and g of x just be two functions. So then we can talk about these specific ideas. I'll try and use, I'll use this cool color over here, okay? So what does it mean then to add two functions, f of x plus g of x? What does that mean? And how do we write it? Well, it means that we want f plus g of x, right? We're allowed to write it like this. So if we're adding two functions, this is the notation that we're going to use. And we're going to say f plus g of x. So the same thing works for f of x minus g of x. It would be f minus g of x. This is what this means, right? They're equivalent on both sides, so they mean the same thing. Okay? If I want f of x multiplied by g of x, well, it's just f times g of x. This is what this means for us. And then lastly, right, if I take f of x divided by g of x, it is f divided by g of x. But we're going to provided that g of x is not equal to 0. The actual g of x function is not equal to 0. So notice that we are adding, subtracting, multiplying, and dividing functions, right? The same things that we do with numbers, we do with functions. In all of these cases, we want to make sure we must always consider the domain of each function. Okay, whenever we're talking about functions, we always want to consider the domain because there may or may not be certain numbers we're allowed to operate on, right? Take the function of. Okay, here's an example. I've got two functions up on the screen here. The one in purple, my f function, f of x, is 4x plus 7. What type of a function is that? It's a linear function, right? So what would the domain be? I'll use the purple to keep everything consistent. What would the domain be for my f function here? The domain would be all real numbers, and that's the symbol I'm going to use is all real numbers. Okay. What about this one, my purple one over here? What's the domain for that one? Is there a number for which we cannot take a square root of in the real number system? Negatives, right? In the real number systems, we don't evaluate square roots of negative numbers. Is that true? Okay. So how do we present this one? The domain for this function is going to be all real numbers x such that x is strictly greater than or equal to 0, right? Because in my g function, I'm not allowed to evaluate g of negative 5, right? Because if I tried to do g of negative 5, I would get the square root of negative 5 plus negative 5. And in the real number system, I don't know what to do with that. There is no number for which I square to get negative 5 out, right? You guys agree with that? We've studied that before? Are you with me? Yeah, this part, if I haven't explained this, this says all real numbers x such that, and then this statement, right? So pick any real number x that you want as long as you pick an x that is greater than or equal to 0. So that little line means such that, which just means pick any x you want as long as, and then the statement on the right says you pick an x that is greater than or equal to 0. That's what that means, Rachel. Okay, so what do we do with this? Let's do part A. Let's do f of x plus g of x, okay? Well, that means, right, f plus g of x. I should have written the right-hand side first. Apologize. So f plus g of x means to take f of x and add it to g of x. But we're going to consider the domains. We've already worked out the domain for each individual one. That's what happens when we add them, right? Well, f of x is 4x plus 7. You guys okay with that? Plus, what's g of x? It's just the square root of x plus an x, right? I'm adding the two functions together. Can I simplify or add like terms? I sure can, right? This would give me what? 5x plus square root of x plus 7. So this is the sum of my two functions. Now, what's the domain for this? Well, to answer that question, I have to go back and say, what do these domains have in common? What are the two domains that they have in common? Not all real numbers, no. Everything that's greater than 0. So the domain for this should be all real numbers such that x is greater than or equal to 0. So I can plug in anything I want to that stuff in the box as long as it's greater than or equal to 0.
F of g minus f of x.
Yeah, this is f of x minus g of x, right? Okay, f of x is, what is it? It's 4x plus 7, right? Okay, now minus g of x is the square root of x plus x. Why do you think I'm going to put parentheses around this here? To remind you that everything to the right of the minus sign is negative, right? So you must distribute your minus sign. So this gives me 4x plus 7 minus the square root of x minus x. If you don't put that bracket in there, those big parentheses, you may forget and write it with that positive x on the back end. So simplifying, I'm going to get, 3x, right? Minus root x, and then plus 7
Shouldn't it be flipped?
for this thing.
All real numbers above 0 or equal to.
Yeah, all real numbers x such that x is greater than or equal to 0. So any real number x as long as the x is greater than or equal to 0. Okay, two more functions. Let's consider their individual domains. Okay, what's the individual domain for f of x? Yeah, how come? This one's all real numbers. Why? There's a reason. It's a quadratic, right? This is all real numbers. The domain for that's all real numbers. What's the domain for my g of x? Yeah, it's a linear function. Linear functions are all real numbers. Sweet, so far so good. Okay, good. Now, let's do this one. Let's do a. Let's do f divided by g of x. Okay? Now, I'm gonna revert back to my definition. Let me scroll up real quick. We can take f divided by g of x, provided that what? Provided that the g, the number on the bottom, the function in the denominator is not 0, okay? So we're gonna consider that at the end. So this literally means take f of x and divide it by g of x, right? Okay, well, what's f of x?
Ooh, this is.
That's x squared minus 9 over g of x, x plus 3.
You get
Anybody recognize that the numerator?
Yeah.
That's a difference of two squares, right? So that's going to be an x plus 3 times an x minus 3, all divided by the quantity of an x plus 3. Okay, you guys are stoked right now because, oh look, we're seeing that that makes a 1.
So you get x minus 3.
So therefore, we get an answer of just x minus 3. So this right here simplifies to that over there, right? And all the math is in the middle. Here's the question. What's the domain of this?
All real numbers.
You guys fell for it. It's not all real numbers.
X doesn't
It's all real numbers x such that x is not equal to what?
0.
No, negative 3. Okay, let's talk about this. Why negative 3? It's the only number that would give you a 0 in the denominator for g of x, right? Remember, g of x is not allowed to be 0. That's what the definition says right there. You guys cool with that part? Okay, so according to my definition, what is g of x? G of x is x plus 3 is not allowed to be 0. Well, what's the only x value that will make this true? Negative 3. That's how I got that right there. Okay?
So then it's fine because it's a 3.
Okay, let's do f times g of x. What does that mean? That literally means f of x times g of x, right? That's our definition. That's our operation for our function. F of x is, what was f of x again? It was x squared minus 9, thanks. Okay, g of x was what?
So you have to do binomial.
V of x was x plus 3, okay? So, all we're going to do is we're going to multiply out. If you guys want to use FOIL, that's fine, whatever. I like to use the box method, but I'm going to speed this up for us. We're going to get an answer of x cubed plus 3x squared minus 9x minus 27. That's what you would get if you multiplied those two binomials together. Okay, so check this out. f times g of x is equal to this big polynomial on the end. What's the domain of that big polynomial on the end? Very good. All real numbers. The domain is all real numbers. I can plug anything I want into any of those x's, any real number, and I will get out a real number. I'm all good. Okay, here's the u-try. There's two functions. I have f, I have g. Okay, one's quadratic, one's linear. So the domain for each is all real numbers. I want you to do f divided by g of x and tell me the domain of the quotient. Oh, shoot. Okay, I got to speed it up just a little bit because we have that assembly coming up, so I want to make sure we're on the right track, all right? So we should have, this is the logic, right? We have f of x over g of x, so I take f of x divided by g of x. Then I factor the numerator, right? And I got 3x plus 1 times x minus 4 over 3x plus 1. Notice that the 3x plus 1s make a 1, right? So they divide out to a value of 1. And that gives me an x minus 4 for the answer. Okay, here's the trick question. What's the domain of this function here?
Except for negative 1/3.
X cannot equal negative 1/3. Yes, very good. Okay, let's talk about function composition. Okay, function composition. This is the last part of our day here. Function composition is taking one function and putting it inside of another function, kind of like a dream within a dream, if you know that Inception thing, okay? So here is the little diagram that really helps kind of explain what's going on here. So I have two functions that are represented by boxes on the page, okay? I'm going to take an input. I'm going to take an input x, and I'm going to put it into my f function. What would come out of this? F of x, very good. F of x would pop out, right? I'm then going to take f of x and plug it into g. What would pop out? G of f of x. Whew, that's a lot of parentheses. Okay, let's do this again. If I took an input like a and I plugged it into the f function, what would pop out? F of a. If I took then f of a, put it in g, what would pop out? G of f of a. Whew. Okay, let's do it one time. Let's do star. If I plug star into the f function, what would pop out? F of star. Very good. If I take f of star and I plug into the g function, what would pop out? G of f of star. Boy, it'd be sweet if there was a better way to write all those notations on the end there, and it turns out there is. Okay, this is written as, we take this information, it's written as this, G of f of x. That does not say goff of x, even though it looks like goff. It's G of f of x. This one, the notation that we say, is G of f of what, you guys? A. And then do the last one for me. What would it be? G of f of star. Okay, so you have to realize that in this particular case, x is inside of f, which is inside of g. Okay? Okay, here's my example for function composition, right? What is f of g of 2? What does that mean, f of g of 2?
That 2 is x.
Yeah, 2 is inside of g, and g is inside of f, right? So what do we do first? This means f of g of 2, right? So I do g of 2 first, right? So g of 2 is equal to what? 4, because 2 squared is 4, right? So this is really now f of 4. How did I get 4? Okay, because I want g of 2. What would g of 2 be? G of 2 is equal to 2 squared, which is 4. Then take the 4 and plug it into f. Yeah. So f of 4 is going to be 4 minus 5, which is then going to be a value of negative 1. So therefore, f of g of 2 is equal to negative 1. Okay, ladies and gentlemen, now I'm asking for g of f of 2. This is the commutative property, right? So instead of f of g of 2, now I want g of f of 2. Should they be the same thing? Someone say yes, someone say no, right? Well, in numbers, right, the commutative property holds. In function composition, though, it doesn't. And then here's an example of why not. Because this means g of f of 2, right? So what do we do first? We do f of 2, right? So we do f of 2. So I take f of 2 first. F of 2 is going to be what? Very good. So this is g of negative 3. Then what do? Take negative 3 and square it till I get 9. So these two are not the same. So it is not always the case that f of g of x and g of f of x are the same thing. It's not always the case. And sometimes it will be, and we'll talk about that on Tuesday.